Okay, so for section 3.1, we are going to learn the product and the quotient rules. We learned in chapter 2, we learned about the power rule. And so we are going to sort of build on this sort of set of rules that we have to take derivatives. So right now, if we were given the function y equals, if we were given this function y equals x squared plus 5 times 2x minus 5, to take the derivative, we would FOIL first. So you would have first would be 2x squared outer minus 5x squared. Oh, that's a cube. 2x cubed. So first outer inner would be 10x. And then last would be minus 25. And then to take that derivative, you would do the power rule several times. So here you would do exponent down front, decrease it by 1. So that would become 3 times 2 times x to the 3 minus 1, which would be 2. So exponent down front, decrease it by 1. Then the 2 goes down in front, so that 5 becomes a 10, x to the first. That 10x becomes just a 10 because it's x to the first. And then the 25 becomes a 0. So you're looking at y prime equals 6x squared minus 10x plus 10. So there's a lot going on there, and these are not that messy. But if this was some sort of quartic function, right, like x to the fourth plus 7x cubed plus 3x squared plus x plus 1 times something x cubed, blah, blah, blah. Distributing first and then taking a derivative would get extremely messy and complicated. So you would like to have a tool to avoid that. And we do, thankfully. It's called the product rule. So something to note here is that the derivative of a product is not the product of the derivative. So we want to be careful about this. Here is the product rule. If you have a function that is the product of two functions, then the derivative is the first function times the derivative of the second plus the second function times the derivative of the first. In my brain, and this is what I was taught, y prime is high d ho plus ho d high. So this is high and this is ho. People do high and low as well, because when we'll do a quotient in a minute, you could add that to it. So first function times the derivative of the second plus the second times the derivative of the first, or high d ho plus ho d high. Or equivalently, if you're looking at u and v, if y is u times v, then y prime is going to be first times the derivative of the second plus the second times the derivative of the first. Okay, so let's do that for the example we just did and see if we get the same thing. So y prime here, this would be f of x, this is g of x, or if you want to use the high ho thing. So you have f of x times g prime, first function times the derivative of the second, plus the second times the derivative of the first. Or if you want to write that as high d ho plus ho d high, then we would have here y prime equals x squared plus 5 times the derivative of g of x. So the derivative of 2x minus 5 would just be 2, because the derivative of 5 is 0, this x has a 1. That's a power rule there. So this would just be 2. Plus 2x minus 5 times the derivative of, actually, maybe I should write that. Hang on. It would be this, 2x minus 5, the derivative of that. So you could do that prime. And then g of x, so 2x minus 5 times f prime, so x squared plus 5 prime. And then you can sort of see it better to do this. So x squared plus 5, the derivative of this guy, which would just be 2, plus 2x minus 5, and then the derivative of this guy, which would be 2x, because this exponent would go down front, decrease it by 1, and then the derivative of 5 is 0. Okay, so in Hawks, you can leave this like this, no need to simplify. But if we wanted to make sure we got the same thing that we did up there just for our own good measure, let's switch to purple. So you, no. So if you were to keep going with this, this would be 2x squared plus 10 plus 4x squared minus 10x. So we did get the same thing. That's 6x squared, and you combine like terms, 6x squared minus 10x plus 10, which is what we got up here. So again, in Hawks, you can stop here. No reason to simplify, just use all the parentheses and you'll be good to go. So let's try a couple more. We have here, this is f of x and g of x again. F times g here. This is y. So y prime would be first times the derivative of the second plus the second times the derivative of the first, or Heidi ho plus ho d high. So here we have x cubed minus 2x plus 1. That's our f function. The g function, we want to take the derivative of. The derivative of this is going to be, that would be 12, because that 4 would go down front. So 3 times 4 is 12. X to the third plus 0. And then let me spread this out so it's clear what's going on maybe. And plus g, which is 3x to the fourth plus 2, times f prime, which is this guy up here. So the derivative of this, x put it down front, decrease it by 1, that would be 3x squared, power rule. And then minus 2x, this is a 1, x put it down front, decrease it by 1, so minus 2 plus 0. Again, you can leave it like that for Hawk. Okay, let's keep going. So I'm gonna not call, I'll call these U and V this time since this is called F. So F prime of X would be U times V prime, first times the derivative of the second, plus the second times the derivative of the first. So we would have 2x cubed, that's our first function. The second function we want to take the derivative of. This v is going to be x to the 1/2 minus 7. So exponent down front, decrease it by 1. And then minus 0. 1/2 minus 1 would be negative 1/2. Okay. So that is u times v prime. And then if we want to scoot this over, plus v, which is the square root of x minus 7, times a u prime, or the first function, the derivative of the first function. That would be 3 times 2, so 6x to the second. And again, you can leave it like that for Hawks. Okay. I think even the negative exponent is fine. I should go back and check. But if it's not, you would go back. This would be 1/2 times 1 over x to the 1/2, or that would reduce to 1 over 2 square root of x. If you have a negative in the exponent, you can move it to the denominator and make it a positive exponent. Okay. So when I look at number 4, I don't want to do the product rule because I don't want to take the derivative of this stuff. And if I, well, if I were to go ahead and distribute this, then that might make it easier, but let's do the product rule for, since that's the section that we're in. This is f of x, just x squared, and then this whole thing is g of x. So y prime is going to be f times g prime plus g times f prime, or Heidi ho plus Heidi high, or first times the derivative of the second plus second times the derivative of the first. Then you have x squared times g prime. That's an x to the, this is an x to the 1/2. So 1/2 x to the negative 1/2 plus this guy is already x to the negative 1/2. So it becomes negative 1/2 x to the negative 3/2. I'll work that out in just a second. Plus g of x, which is the square root of x plus 1 over root x times f prime, which would just be 2x. So going back up here, g prime of x, actually, let's just start back with g. So g of x, this is going to be x to the 1/2 plus x to the negative 1/2. That's what square root of x and then 1 over square root of x is. So then g prime of x, you would do exponent down front, decrease it by 1. 1/2 minus 1 would be negative 1/2, plus exponent down front, decrease it by 1. So negative 1/2 minus 1 is, it would be the same thing as doing minus 2 over 2, so negative 3/2, which is what we have here. Okay, so this is your answer you would put in Hawks. Okay, and then number 5, this is f again, so I'll do, this is u and this is v. So f prime of t would be u times v prime plus v times u prime. Put that out some here. So u is 1 minus 3 over t squared. V prime would be exponent down front, so that becomes a 4t to the first, the 2, so take 1 away, that would give you 1, and then plus t to the first, so exponent down front, decrease it by 1, so this would just be plus 1, and then plus 0. And then 2t squared, that's v, this is v, times u prime. So the derivative of this guy is 0, and then we need to take the derivative of this. That is negative 3 times t to the negative 2. So exponent down front would make that positive 6, negative 3 times negative 2. So positive 6 t to the negative 3. And again, you don't need to simplify for Hawks. Okay. So that is the product rule and several examples of that. If y'all have questions about that, just email me. If you'd like to see any of those in more detail, just email me and let me know. Okay, so now we'll move to a quotient. And currently, if I asked you to take the derivative of this thing, you would simplify first and then try to do the power rule several times. So you would simplify this. This would become, x cubed over x squared is just x. And then this would be 2x to the negative 1, and then minus 4x to the negative 2. Putting each of these over x squared and then simplifying. So x cubed over x squared is just x. 2x over x squared, you get 2 over x, which is 2 times x to the negative 1. And then 4 over x squared would just be 4 times x to the negative 2. So then when you take a derivative, you do the power rule. This is a 1. So exponent down front, decrease it by 1. That would give you a 1. Exponent down front makes this negative 2x to the negative 2. Exponent down front, decrease that negative 1 by 1. That gets you to negative 2. Here, exponent down front is going to make that positive 8x to the negative 3. Okay, so that's how we currently do this. And again, that's not that bad because we can simplify. This thing. But if this wasn't just an x squared, like that would get pretty messy and you can't do it. So we need to have another method. And that method is called the quotient rule. So if y is equal to the quotient of two functions, so f of x over g of x, division there, then y prime is g of x times f prime of x minus f of x times g prime of x over g of x squared. So the only way, because of this subtraction, order does matter on the top here. So again, I call this high and this ho. Some people call it low, which makes sense here for this quotient. So let's say ho be high minus high d ho, or low, right? So low d high minus high d low over low low, or ho ho, which is how I learned it. So ho or low d high minus high d low over low low. Or if it's written, like if you're looking at u over v, it would be, I don't have space for this. Here, y prime would be v, so low d high minus high d low over low low. Okay, so let's do this with the example we just did and make sure that that works. Make sure we get the same thing. So this is f of x over g of x. So y prime is going to be g times f prime, low d high minus high d low, derivative of the lower function, divided by low low. So square that bottom. So we would get here, and this is thankfully where you don't have simplify in Hawks, which is really nice. But low, which is just x squared, or g of x, d high, so the derivative of the top, that would be 3x squared plus 2. Exponent down front, decrease it by 1, that gives 3x squared. Exponent down front, decrease it by 1 gives just 2. So we have ho d high minus high, so x cubed plus 2x plus minus 4. And then the derivative of the bottom function, that's just 2x. And then all of this over x squared squared. I don't want to do the math to figure out if those are the same. We could graph it and look. Let's do that. Okay, so if we go to Desmos and graph those and make sure they look the same, y equals the way we did the derivative with the power rule, I have 1 minus 2x to the negative 2, and then plus 8x to the negative 3. And we want to make sure that's the same as y equals, oops, this quotient, which is x squared times 3x plus 2 minus x cubed plus 2x minus 4 times 2x over x squared. Uh-oh. Hmm. X squared minus 8 I don't know why those don't match. I will look at that later and not waste more time on this video, so I will look at that later. Anyway, that is the quotient rule for that one, and we can keep going. If you look at something like number 2, last week, we wouldn't have been able to take that derivative because this doesn't, you can't simplify that. So luckily we have the quotient rule now. So this is f of x over g of x. So y prime would be low d high minus high d low over low for g of x squared. And so we have then g, which is x cubed minus 3 times the derivative of the top, which would just be 3. The derivative of this is a 1, exponent down front decreased by 1. The derivative of a constant is 0. So